Welcome students of class 11 and welcome you all to your new session. Now I am your chemistry teacher and today I will discuss on the chapter that is states of matter which comes under the physical chemistry. All of you know that your chemistry paper contains two books, part 1 and part 2. This is from part 1. So the chapter is states of matter. Now all of us know that there are three states of matter, that is solid, liquid, gas, and these are the three general states and two special states are there, that is one is Bose-Einstein condensate and another one is plasma state. These are two special states exist within the universe. Now solid, liquid, gas, there is a intermolecular force or intermolecular interactive force which is acting within the molecules and giving the states, that is solid state, liquid state and gaseous states, and intermolecular force is maximum in solid and minimum in the gaseous state. Now later on we have to know the types of force acting within the molecule. So that is Van der Waals force. Van der Waals force is the intermolecular attractive force. Intermolecular attractive force is known as Van der Waals force. Now Van der Waals force comes under four different kinds of force. One is the London force. London force. It is named by the discovery of scientist London, Fritz London. Next one, that is dipole-dipole force. Dipole-dipole. Third one, dipole-induced dipole. And fourth one, that is hydrogen bonding. Instead of that, there are another kind of force which is different from Van der Waals force. This is known as ion dipole force. Ion dipole force. So first of all, the Van der Waals force comes under London force, dipole-dipole force, dipole-induced dipole and hydrogen bonding. And another one, that is ion dipole force. So first of all, what is London force? So London force is a type of force where two symmetrical atoms are induced by presence of some polar molecules, where two symmetrical molecules or atom A and B, here charge are symmetrically distributed, and if in presence of some external force, if A becomes induced, then it will induces the B. So this type of force is known as London force, and London force is a very small range force and it varies with the distance of the internuclear separation. This internuclear separation 1 by r to the power 6 is r is the distance between the two nuclei. Now it is a small range force and it acts in presence of some external dipole or external field. Next one, that is dipole-dipole force. Next one, that is dipole-dipole. So dipole-dipole means here already a charge is separated or the molecule is already charge separated. Suppose example is HCl. Here we know that the electronic charge are distributed towards the chlorine atom, as chlorine is more electronegative. In this way, here also the chlorine atom, hydrogen, chlorine. So here already a dipole. This dipole will interact with the another dipole. This kind of force is known as dipole-dipole interaction. Third one, that is dipole-induced dipole. Dipole-induced dipole. Here, presence of one dipole plus one non-polar molecule. One dipole, another one non-polar molecule. Suppose one dipole, that is AB, it is delta plus, is delta minus. Now another one, that is XY. Now in presence of delta positive charge on B, it will interact with that, forming delta negative and delta positive. So this kind of interaction is called dipole induced dipole interaction. And another one, that is hydrogen bonding. Hydrogen bonding. Here also, due to the electronegativity difference between hydrogen and an electronegative element, suppose HF. So here fluorine will then take the negative charge, delta negative charge, and hydrogen will take the delta positive charge. So in the HF molecule, so it will take delta plus, delta minus, HF, delta plus, delta minus. This kind of force also we can find it in water molecule also. HOH, it is delta minus, is delta plus, delta plus. Here this is known as hydrogen bonding. Here also hydrogen bonding. So these are the special types of bonding that is known as hydrogen bond. But hydrogen bonding is a special kind of force, that is there should be a large difference in electronegativity. Now these are comes under van der Waals force. Van der Waals force, that is, one is London force or dispersion force, another one is dipole-dipole force, third one is dipole-induced dipole force, and fourth one is hydrogen bonding. Now next one, that is ion dipole interaction. So in presence of an ion and also a dipole, there is the stability is gained within the molecule. This will works as a stability factor to the molecule, that is ion dipole interaction. So these are the types of interaction, and these are responsible for various physical and chemical properties of a molecule. Now next point, that is you have to know that what is gas and some gaseous rules. Now gas, as we know that there are least intermolecular force within the molecule. Now there are different laws under the gas, that is we have to take three consideration, that is pressure, volume, and temperature. Now keeping one constant, keeping one parameter constant, we have to vary the other two. Keeping one parameter constant, we have to vary other two, and the change in the other two parameters comes under different rule, that is the Boyle's rule, Boyle's Charles Avogadro's, Gay-Lussac, etc. These are all gas rules. So first of all, what is Boyle's rule? Boyle's rule. Boyle has taken into consideration that is temperature remains constant. So when temperature of a fixed volume of gas remains constant, then the pressure is inversely proportional to its volume. When temperature remains constant, then pressure is inversely proportional to its volume. When temperature is constant. Here T, that is T in Kelvin scale. So P varies as 1 by V. P, if we take one proportionality constant, then it becomes K into 1 by V. So it will be the mathematical form of Boyle's rule. That is P equal to K into 1 by V, where K is the proportionality constant. Proportionality constant. So if we take the corollary, that is P1 equal to K into 1 by V1 and P2 equal to K into 1 by V2. So from these two equations, we can tell that P1 by P2 equal to V2 by V1. This is also an important rule or extension of the Boyle's rule, which will work for our mathematical problem. So P varies as 1 by V. This is the mathematical rule, and P1 equal to K into 1 by V1 and P2 equal to K into 1 by V2, and then P1 by P2 equal to V2 by V1. Now next point, that is about the curve. That if we curve or if we plot the pressure volume curve for Boyle's rule, then it is of that type y equal to mx plus c. So here it is P, it is 1 by V. Then at different temperature we will get different plot. P varies as 1 by V, and if we plot P versus V, then it will be a hyperbolic curve. So if we plot P varies as 1 by V, keeping T constant, then we will get a straight line passing through the origin, and at different temperature we will get different plot. But if we plot P varies as V, then we get some hyperbolic curve. So Boyle's rule, that is when temperature remains constant, then pressure of a certain volume of gas is proportional to its volume. Next one, that is the curve, that is straight line curve is followed for the P varies as 1 by V, and a hyperbolic curve is followed for P varies as V. In the next class, we will discuss on the another rules, that is the Charles rule, Avogadro's law, Gay-Lussac gas law, etc. Now you have to thoroughly read your NCERT textbook regarding the types of force, that is van der Waals force, and the examples and the application of it, and next one, that is the gas rule, that is up to the Boyle's rule, and the problem regarding this Boyle's rule will be discussed on the later class. So for this class, just the introductory portion of this chapter and the simple rules are discussed. On the next class we will discuss the latter portion. Thank you.